Okay, let's get right into this stack of sources you've shared with us. They're
Mm-hmm.
diving deep into how we build these, well, massive, complex websites these days.
Yeah, and they keep circling back to one concept that seems to be, shaking up front-end development.
Microfrontends.
Exactly, microfrontend.
So what is that fundamentally?
Well, it's an idea borrowed really from the back-end world, microservices.
Sure, breaking down big applications into smaller, independent services.
Right. So microfrontends, they apply that same thinking, that same philosophy, but to the user interface, to the front end.
Ah, okay. So instead of one giant sort of tangled front-end code base,
Yeah, the monolith.
you're breaking it into smaller, self-contained pieces. Is that the idea?
That's precisely it. The goal is for different teams to actually own, manage, and deploy their specific parts of the UI code.
Independently.
Independently, that's the key word. Even though for the user, it all looks like one single cohesive website.
Got it.
Yeah.
Okay, so our mission then for this deep dive is to really get a handle on what microfrontends are, fundamentally.
Right. And importantly, why teams are even going down this road. I mean, it sounds complex.
Yeah. Why bother with the extra complexity? What are the benefits?
And then how it all fits together, the different technical approaches.
And of course, the trade-offs. What are the real world challenges?
Yeah, absolutely. We need to explore the principles behind it first, though. Things like single responsibility, loose coupling.
High cohesion.
High cohesion, yeah. These aren't just buzzwords. They're kind of critical to making the whole thing manageable.
And we should look at where the sources say this actually makes sense. When should you even consider this?
Good point. It's definitely not for every project. Primarily, you see it when you've got a really large application.
Or lots of teams working on it.
Multiple development teams, yes. Or maybe even a mix of different technologies in your stack.
Like migrating from an old framework.
Exactly. Basically, when the complexity of that big monolith starts causing more pain than the complexity of managing these distributed UIs.
Okay. Now, here's where I think it gets really interesting.
Mm-hmm.
How do you actually do this? How do you implement them?
Right. The sources cover quite a few ways. Some are more, let's say, traditional
Server-side stuff.
server-side composition, yeah. Even Iframes get mentioned.
Iframes, really? Okay.
And then there are the more modern dynamic approaches. Module federation is the big one there.
Module federation. We'll need to unpack that. And single SPA. Yeah.
And single SPA, yep. We'll compare them, based on things like deployment, independence, performance.
Setup effort, I bet that's a big one.
Oh, yeah. Setup effort. How they handle things like authentication, which is always fun.
Always. And we absolutely have to talk about the challenges, like you said, especially with these modern methods.
For sure, because they introduce whole new sets of complexities. Technical hurdles like managing dependencies, avoiding style clashes.
And operational stuff, like deploying and monitoring all these little pieces.
Exactly. Deployment strategies, monitoring, observability, even just how teams communicate.
Okay. And to make it concrete, we'll look at some examples from the sources, right? Spotify, IKEA.
Yeah, see how they've tackled their specific UI problems using this approach? Pull out some real-world insights.
All right, sounds like a plan. Let's jump in. So what's the fundamental driver here? Why move away from that monolith front end, which seems simpler on the surface?
Well, think about that large traditional front-end app. It often grows into this massive code base, right? A monolith.
Yeah, I've seen those. Terrifying.
And every team working on any part of the UI, they all have to coordinate their releases. Even a tiny change somewhere.
Requires a full build and deployment of the whole thing.
Exactly. And that just slows everything down to a crawl.
Oh, I've definitely felt that pain. A small CSS fix in the footer holds up a major feature launch because it's all tied together in one deployment pipeline.
That's the classic scenario. Microfrontends aim to fix that. The idea is letting teams own a vertical slice of the application, from their own back-end service right up to their piece of the UI.
Owning the whole slice.
Yeah. And the core motivation, really, as the sources keep highlighting, is enabling team autonomy.
Autonomy. So the checkout team can just deploy their UI changes whenever they're ready.
Precisely. Without needing a meeting or coordinating with a team working on, say, the product catalog page, they can just build, test, and ship.
Much faster iteration, though.
Potentially, yes.
No.
Much faster.
That autonomy does sound powerful. Does it also help with, reducing deployment risk?
Absolutely. It stands to reason, right? Deploying a small, isolated piece is inherently less risky than deploying the whole giant thing at once.
Yeah, something breaks.
The blast radius is smaller. It might affect just that one microfrontend, not bring down the entire site.
Okay. And for big companies, this sounds crucial for just scaling the development effort itself.
It is. You can have many teams working in parallel on the front end without constantly, tripping over each other in that single shared code base.
Scaling the organization, essentially.
You did. But to make this work, you need some rules, some guiding principles. The sources point to ones very similar to microservices.
Okay, like single responsibility.
Scale responsibility principle, yeah. Each microfrontend should ideally have one clear job, one focused feature area.
So it's responsible for rendering and managing, say, the login widget or the shopping cart view.
Exactly. Like a super component almost that owns its own destiny.
And loose coupling. That sounds important.
Oh, critical. It means these different pieces shouldn't have deep, tangled dependencies on each other. They shouldn't know too much about each other's insides.
How do they interact then?
Through well-defined, stable interfaces. Maybe they send messages, maybe they use a shared event bus, maybe they call a common API gateway, but they avoid direct calls into each other's internal code.
Right. So one team can refactor their microfrontend.
And as long as they don't break that public contract, that interface, nobody else needs to change or even know. That's the goal. Allows them to evolve independently.
That makes sense. And high cohesion.
That just means all the bits related to a specific feature, the logic, the styles, the markup for, say, the login widget should live together within that microfrontend unit.
You don't want login logic scattered everywhere.
Exactly.
Okay.
Keep related things together.
Okay, these principles make sense. They sound like the guardrails you need to stop this distributed system from becoming just another kind of mess.
Pretty much. They help maintain sanity.
So when is this whole approach actually a good idea? When is it warranted? The sources are clear it's not a default, right?
Definitely not. The main trigger is usually having a large and complex application. If your app is small, maybe just a few pages.
A monolith is probably fine, simpler even.
Probably, yeah. The overhead of microfrontends wouldn't be worth it.
And the number of teams.
Multiple development teams is another big indicator. If you just have one small team, the autonomy benefits aren't really there. The organizational structure often drives this decision.
Makes sense. What else?
Another big one is when you have or want diverse technology stacks.
Ah, the migration scenario again.
Exactly. Maybe you're stuck on an old Angular.js app, but you want to start using React or Vue for new features.
Microfrontends let you do that incrementally.
Yes. You can build a new feature as a microfrontend using the new tech and integrate it into the existing application shell. You rewrite section by section rather than attempting that scary, risky Big Bang rewrite.
That is a huge practical advantage, avoiding the big rewrite.
It really is.
Yeah.
And finally, scalability is often mentioned, both scaling the number of developer teams, as we said, but also potentially scaling specific parts of the application differently based on user load, though that's often more about the back-end architecture supporting the microfrontends.
Okay, that gives us a solid foundation. We've got the what, the why, and the when. Now, let's dig into the how, the implementation patterns. The sources start with some older ones, right? Server-side composition.
Right. This is one of the more traditional ways. It happens, as the name suggests, on the server.
Before the page even gets to the browser.
Exactly. You typically use something like a reverse proxy or an application gateway. It looks the incoming URL.
Like the path, profile, or checkout.
Precisely.
Mm-hmm.
And based on that path, it routes the request to different independent back-end applications.
So the profile team has their own back-end app. The checkout team has theirs.
Yep. And the server or the gateway essentially stitches together the HTML fragments it gets back from these different applications into one complete page before sending it down to the browser.
Okay, so that definitely allows for independent deployments, right? The profile team can deploy their app without coordinating with checkout.
It does. That's a key benefit. Each team owns their route and their back-end service.
Well, I feel a bud coming. What's the catch?
The main drawback, highlighted in the sources, is the user experience. Navigating between these different sections, let's say, from profile to checkout.
Often means a full-page refresh.
Exactly. You lose that smooth, seamless, single-page application feel, where navigation feels instant because only parts of the page are updating via JavaScript.
Right, you don't get that SPA magic.
You often don't. Plus, you might end up duplicating common UI elements like headers, footers, navigation bars across all those different server-rendered applications.
Okay. So great for team independence based on URL routes, but maybe less ideal for that modern, fluid web app feel. What about iframes. You mentioned iframes.
Yeah, iframes get mentioned. They are a very old method, technically. It's
Oh,
just
yeah.
the standard HTML iframe tag.
For embedding content from somewhere else.
Right. Think embedding maybe a legacy piece of an application, or more commonly a third-party widget, like a chat support bubble or weather forecast.
Seems simple enough.
Hmm.
And the content inside the iframe is definitely independently deployable.
It is. Very isolated. But the sources are pretty clear, and I tend to agree there are significant drawbacks for using them to build your core application UI.
Like what?
Well, they're heavily isolated sandboxes, which is good for security sometimes, but bad for integration. They load their own dependencies, which can really hurt page load performance.
Right, loading React twice, for example.
Exactly. Communication between the iframe and the parent page is notoriously difficult. It requires complex post-message setups. You hit layout issues, resizing problems, security restrictions like cross-origin policies.
Accessibility issues, too, I bet, and SEO.
Yeah, SEO and accessibility can be tricky with iframes. So unless you have a very specific reason for that kind of heavy isolation, like embedding untrusted third-party stuff,
They're generally not recommended for building the main parts of your own app.
pretty much. They often create more problems than they solve in that context.
Fair enough. Okay, what about integrating things at build time? Using packages, like NPM packages.
Yeah, that's a really common approach, especially for sharing reusable UI code. You build a component, maybe a set of components for a design system, or even a whole section of UI.
And publish it as an NPM package.
Exactly. Then other teams install that package as a dependency in their own project using NPM or Yarn.
Just like installing, say, a date picker library or something.
Precisely. That package code then gets pulled in during the build process of the main or host application. The host bundles it all together with its own code before deployment.
Works well for things like shared buttons, design tokens, maybe utility functions.
Yeah, static UI components, shared styles, utilities, it's great for that.
But this doesn't sound like truly independent deployment for the package component itself, does it?
Ah, you hit the nail on the head. That's the key limitation.
If the team owning the shared button package updates it.
The host application doesn't automatically get the update. The host team needs to explicitly update the package version in their package.json, rebuild, and redeploy their entire application.
So deployments are coupled.
Deployments are coupled. A change in the shared package requires every consuming application to update and redeploy. While you can manage dependencies between packages to reduce duplication, just handling versions and avoiding conflicts across many apps can become a real operational headache.
So it fits certain use cases.
Yeah.
Where that coupling is acceptable or even desired.
Exactly. It's good when you want that explicit version control and upgrade path by the consuming applications. Think shared design systems where consistency and controlled rollouts are key.
Okay, so these traditional methods, they have their uses, but they either sacrifice that fluid SPA feel, like server composition, or they tie deployments together, like packages.
Or they come with a host of other issues, like iframes.
Right, which leads us neatly into the modern approaches. And module federation seems to be the one generating the most buzz.
It really is. Module federation, it's kind of a game changer because it enables runtime integration of UI code.
Runtime, as opposed to build time.
Exactly. Instead of pulling code in when you build your app or stitching HTML on the server, you can load components or even whole chunks of applications dynamically in the browser while the user is actually using the page.
So the browser downloads the component code only when it needs it, like on demand.
That's the core idea. Think of it like maybe your blog page wants to show a related articles widget. That widget could be a separate microfrontend, maybe hosted on a different server or domain entirely.
Okay.
Your blog page application, the host, is configured to know where to find that widget microfrontend, the remote. When the user scrolls down, the host can dynamically fetch the JavaScript code for the widget from the remote.
And just display it seamlessly,
Yeah.
without a page refresh or an iframe.
Precisely. One application, the remote, exposes specific JavaScript modules like that related articles widget component. The host application knows where to find the remote's remote entry.js file, which is like a manifest.
And the host code just imports the remote component almost like it was a local file.
That's the magic of it, yeah. Webpack's Module Federation plugin, or similar build tool plugins, handles the complex loading and wiring behind the scenes. The host basically says, hey, Module Federation, I need the related articles widget from the articles remote, and MF figures out how to load the code and make it available to the host's JavaScript.
Wow, okay. And you mentioned dependencies. How does it avoid loading React 5 times if 5 different remotes use it?
The shared configuration. This is absolutely critical for performance.
Okay.
Both the host and the remotes can declare which dependencies they use, like React, React DOM, maybe a big charting library, and which versions they are compatible with.
And Module Federation sorts it out.
It negotiates at runtime. If the host has already loaded React version 18 and a remote also needs React 18, Module Federation ensures the remote just uses the host's instance instead of downloading its own copy.
Clever. What if versions clash?
It has strategies for that too. It can be configured to use the highest compatible version or warn you or potentially even load multiple versions if absolutely necessary, though you try to avoid that for performance. But the goal is share as much as possible,
So you get that runtime integration, that independent deployment capability.
while still maintaining good performance and that fast, smooth SPA feel. That's the promise.
Fetching and sharing code dynamically in the browser. That sounds incredibly powerful for enabling truly independent teams.
Okay, what about single SPA? That's the other modern one mentioned.
Right, single SPA. It's often discussed alongside Microfrontends. You can use it with Module Federation, but its primary focus is slightly different.
How so?
Single SPA's main strength is orchestrating multiple applications, potentially built with different JavaScript frameworks, all running together within a single page.
Okay, so it's less about how the code gets loaded dynamically and more about managing, say, a React part of the page living next to an Angular part or a Vue part. Exactly. Think of single SPA as a top-level router and lifecycle manager. You register different single-spot applications with it. Each of these is typically written in a specific framework, React, Angular, Vue, Svelte, whatever, and is responsible for a certain part of the UI, often based on the URL route.
And single SPA's job is?
Its job is to figure out, based on the current URL or other conditions, which applications should be active. It then handles mounting them, basically, starting them up and rendering them, and crucially, unmounting them, cleaning them up properly as the user navigates around.
So if my entire application, all the microfrontends, are built using just one framework, like React, do I still need single SPA?
That's a really good question, and a key takeaway from the sources. Probably not, or at least its main benefit is reduced. If you're all in on React, Module Federation alone might be perfectly sufficient for sharing components or loading different parts of the UI dynamically.
Single SPA adds that extra layer of orchestration complexity, mainly for the multi-framework scenario.
Primarily, yes. That's where it really shines. It doesn't actually handle loading the code itself, by the way. You still need a strategy for that, maybe System.js imports, or often Module Federation is used underneath single SPA to provide the code for the different framework applications.
Okay, that clarifies the distinction nicely. Module Federation is more about the runtime code integration and sharing. Single SPA is about orchestrating potentially different framework apps on the same page.
Well put.
Right. Now, let's try to stack these approaches up against each other, based on some key factors. Independent deployments, who wins there?
Well, Module Federation is designed for this. Remotes are loaded at runtime, so they can be deployed completely independently of the host or other remotes.
Okay.
Server-side composition also allows it, but it's usually tied to URL routes. Iframes technically are independent. The big loser here is build time packages.
Because the host has to redeploy to get the update.
Exactly. Deployments are coupled.
Performance. Always crucial for the front end.
Module Federation aims for good performance, especially with that shared dependency mechanism. It tries to keep the SPA feel.
Server-side comp.
Often results in full-page reloads, which feels slower.
Iframes.
Generally poor performance due to isolated loading, duplicating resources.
And packages.
Can perform well if dependencies are managed carefully via externals or peer dependencies, but there's still a risk of duplication if not done right, and the initial load might be bigger if everything is bundled upfront.
Okay. How about setup effort? Getting started.
This is where Module Federation can bite you initially. There's a definite learning curve. Figuring out the Webpack config, the shared settings, the remotes. It can be tricky.
Need some build tool expertise.
Definitely. Server-side composition is maybe simpler at the application level, but you still need to configure the proxy or gateway. Iframes are easy to add initially, but then managing the communication and edge cases becomes hard.
And packages.
Packages require setting up a publishing process, versioning strategy, maybe a private registry. So effort there too, but perhaps more familiar territory for many teams.
Scalability and ongoing maintenance.
Module Federation seems to scale well organizationally. Breaking the UI into smaller owned remotes makes things more manageable, limiting the scope of changes. This should help maintainability over time.
Server-side comp.
Can lead to code duplication across the different server apps, like common UI or logic.
Iframes and packages.
They both add maintenance overhead due to their specific limitations, communication for iframes, version management, and deployment coupling for packages.
Right. And what about shared concerns? Like how do you handle user authentication across these different pieces?
Good one. With module federation, the remotes usually need to exist within the host's authentication context. This might mean the host passes down an auth token or ensures session cookies are correctly sent when a remote makes an API call.
Which can get tricky with cross-domain requests.
Exactly. If your remotes are on different domains than the host, you need to handle cores correctly and make sure credentials are included when needed. It requires careful setup.
Server-side composition.
Often integrates with some central authentication service or relies on session management handled by the gateway.
Iframes.
Secure cross-domain authentication with iframes is notoriously difficult and often discouraged.
And packages.
Packages just run as part of the host application, so they typically just relied on whatever authentication mechanism the host uses.
Okay. Last comparison point. The developer workflow. Like how easy is it to develop and test locally?
Module federation has made strides here. You can often run your host application locally and configure it to pull remotes either from a deployed environment, like staging, or even point it to another microfrontend running locally on a different port.
So you can test the integration live.
Yeah, which is a big improvement over trying to simulate complex server-side composition locally, or dealing with iframe quirks, or manually linking packages using tools like npm link or Yalk, which can be fiddly.
Okay, so summing up the recommendations from the sources, module federation seems generally preferred when?
For complex SPAs, where you have multiple teams needing true independent deployment, runtime integration, and you want to maintain that smooth user experience.
Server-side composition.
Maybe better for sites with more distinct sections tied to URLs, where full page reloads between sections are acceptable, or perhaps where server rendering for SEO is a primary concern for every view.
Iframes.
Best avoided for your core application UI. Reserve them for isolated third-party embeds where you really need that sandbox.
And build time packages.
Still very suitable for sharing reusable libraries, design systems, utility code, where that explicit version control and coupled deployment model makes sense or is acceptable.
Okay, that comparison really helps position each approach. But you mentioned earlier, especially with the modern ones like module federation, there are real complexities. Let's dig into those challenges.
Right, yeah. It's definitely not a magic wand. The biggest hurdle people often hit first with module federation is that initial setup complexity.
Getting the build tools right.
Exactly. You really need to understand how Webpack, or your chosen bundler, works, how it handles modules, chunks, dependencies. Getting that shared configuration tuned just right to maximize sharing, but avoid version conflicts. It takes effort and experimentation.
Okay, so you get past the setup. What headaches await you at runtime? In the browser.
Well, cross-domain issues are a big one if your remotes aren't hosted on the same origin as the host.
Chorus configuration.
Yep. You need to get your cross-origin resource sharing headers set up correctly on the servers hosting the remotes. And dealing with credentials, like cookies for authentication, across domains requires careful handling, with credentials, same-site attributes, etc.
What else? Styling. I can imagine CSS clashes being a nightmare.
Oh, absolutely rampant if you're not careful. How do you stop the CSS from remote A accidentally messing up the layout or styles of the host, or remote B?
Global CSS is dangerous here.
Very. You really need robust strategies like CSS modules, styled components, shadow DOM, though that has its own complexities, or strict naming conventions like BEM combined with careful scoping.
Okay, so technical hurdles. What about the operational side? Deploying these things, keeping them running.
That gets more involved too. First, where do you host all these independently deployable JavaScript bundles for your remotes?
Not necessarily on the same server as the host app.
Often not. A common pattern mentioned in the sources is using cloud storage, like an S3 bucket or similar blob storage.
Why S3?
Cheap, reliable, scalable, easy to deploy static files to. But then you need a really smart caching strategy.
Because you want users to get updates, but you also want performance.
Exactly. Most of the JavaScript chunks can probably have long cache lifetimes, cache busting via file names, but that main remote entry.js file, the manifest that tells the host what modules are available and where to find them, that needs to be non-cached or have a very short cache time. Otherwise, the host won't see newly deployed remote updates quickly.
Tricky balance. And monitoring. How do you even know what's going on across all these distributed pieces?
Observability becomes much harder. Your standard analytics or error tracking needs careful thought. How do you trace a user's journey or an error if it crosses the boundary between the host and one or more remotes?
You need more sophisticated tooling.
Yeah, things like distributed tracing become more important, so you can see how a single request or user action flows through the host, potentially multiple remotes and maybe their respective backend services. You need logs and metrics aggregated from all these pieces. And then there's the question of how these independent pieces actually, talk to each other or share state if they need to.
Right. If they're loosely coupled, they shouldn't be calling directly into each other's code. So how do they communicate?
Good question. The sources suggest a few patterns. Simple things like using standard browser custom events for broadcasting information.
Like the cart remote fires a cart updated event.
Exactly, and maybe the header remote listens for that to update the item count. You could also potentially share an instance of a state management library like Redux or Zoostan, but you have to be careful that doesn't create too much coupling again.
What else?
Sometimes communication happens indirectly via the backend. One microfrontend triggers an API call, which updates data, and another microfrontend eventually reflects that change when it fetches data. Or you could use a more formal front-end message bus or pub subsystem. The choice depends heavily on how tightly coupled the interaction needs to be. This also ties into how they interact with backend services. You often move away from one giant backend API for the monolith.
Towards the back-end front pattern, the BFF.
Exactly. The BFF pattern often emerges naturally here. Each front-end team or micro-front-end might own its own dedicated back-end service specifically designed to serve its UI needs.
So the BFF for the product details microfrontend only worries about fetching product data, reviews, etc., simplifying things for that specific front-end piece.
Precisely. It aggregates data, shapes it perfectly for the UI, reduces the amount of logic needed on the front end itself. But now you have multiple back-end services too.
Which means you need things like API gateways to route requests.
Right, and consistent authentication and authorization across all those services, maybe using something like JWTs, and careful data fetching strategies on the front end.
Wow. Okay, so this distributed nature, front and back, it fundamentally changes the whole development process, doesn't it? And texting.
It really does. Your team structures might need to adapt, maybe cross-functional feature teams owning a slice end-to-end. You absolutely need robust CI/CD pipelines for each micro front-end to enable those independent deployments safely.
And testing gets more complicated.
Multi-layered. You still need unit tests within each micro front-end. You need integration tests to ensure a micro front-end works correctly with its BFF or back-end services. But then you also need reliable end-to-end tests.
Testing flows that might span multiple micro front-ends.
Exactly. Simulating real user journeys across these boundaries becomes crucial, but also more brittle. And contract testing is often mentioned as important.
Contract tests. To check the APIs.
Yeah, to ensure that the contracts, the agreed-upon API interfaces between micro-frontends and their backends, or even between micro-frontends if they communicate directly via events or messages, remain compatible as teams evolve their code independently.
Prevent breaking changes.
That's the goal.
And security. I imagine distributing the UI introduces new security considerations.
It does. Isolation is key, but it's not always perfect like an iframe.
Yeah.
You need to ensure consistent and secure authentication and authorization across all pieces, using HTTPS everywhere, secure tokens like JWTs properly, rigorous input validation in each micro front-end and its backend.
Because a vulnerability in one could potentially compromise others.
Potentially, yes. You need defense in depth. Web sandboxing techniques can help where applicable. The principle is that compromising one micro front-end shouldn't automatically grant access to the whole application or all user data.
Okay, that's a lot of challenges to navigate.
Yeah.
Let's bring it back to those real-world examples to see it in practice. Spotify and IKEA. What did the sources say about how they used micro front-ends?
Well, Spotify is mentioned particularly in the context of their desktop client, which is largely web tech under the hood. It's a complex application.
Yeah, you've got the player, the library, search, discovery feeds, friend activity.
Exactly. Using microfrontends allowed different teams to work independently on those distinct sections. The team working on the player controls could iterate and deploy separately from the team working on the library view, for example.
So it was a way to manage that complexity, scale the teams, and speed up feature delivery in different parts of the app.
That seems to be the motivation, yeah. Managing a mature, complex application built by many teams over time.
At IKEA. They were redoing their whole online experience, right?
Right. The sources suggest IKEA used this approach as part of breaking down their large, monolithic e-commerce platform.
To allow faster iteration on different parts of the customer journey.
Seems likely. Maybe the product listing page team could move faster, or the team focused on the checkout flow could experiment more easily. It helped them build a more flexible architecture overall.
Supporting their whole omni-channel strategy, too. Like trying to get a consistent experience across web and mobile.
Yeah, building reusable independent pieces likely contributes to that goal as well, allowing them to compose different experiences from the same core UI components or sections managed by independent teams.
These examples really highlight the kind of scale, the kind of complex organizational and technical problems that microfrontends are really designed to address.
Absolutely. Even with all the challenges we just discussed.
Look, they're significant.
They are significant. But these examples show that for certain kinds of large-scale applications and organizations, the benefits in terms of development velocity, team autonomy, and managing that inherent complexity can outweigh the costs.
Wow, okay. We really have covered a lot of ground here.
Okay.
We went from the basic idea, breaking up that front-end monolith.
Inspired by microservices.
Right. Explored the core principles like loose coupling and autonomy. Walked through the whole spectrum of implementation patterns.
From the old school server-side rendering and iframes.
Dual time packages.
And then the really dynamic runtime stuff like module federation and the orchestration capabilities of single SPA.
And then we spent a good chunk of time really facing the complexities, the trade-offs, the operational realities.
Yeah, the setup hurdles, the runtime headaches like cores and styling, the deployment and monitoring challenges. It's not simple.
Definitely not simple. But I think we've seen there's no single best way. The right approach really depends heavily on your specific situation.
Totally. Your team structure, your existing tech stack, how much independence you truly need, what kind of user experience you're aiming for, it all feeds into the decision.
So hopefully you listening now have a much clearer picture of what this micro-frontend architecture actually entails.
When it might be a powerful tool to consider.
And crucially, the kinds of technical complexity and, just as importantly, the organizational shifts you need to be ready for if you go down this path.
It's a significant architectural decision, not something to jump into lightly.
Which brings us to a final thought, maybe something for you to chew on. If the core benefit, the driving force behind microfrontends, is empowering teams to work so independently on their slice of the UI, how does that change the way teams need to coordinate between themselves? What new kinds of alignment, maybe shared standards or communication patterns, become absolutely essential to make sure the end user still gets a single, seamless, high-quality experience?
That's a great question. How do you maintain overall coherence, visual consistency, performance standards, a logical user journey when different teams are shipping different parts of the same page, potentially at different times?
Yeah, what does that cross-team collaboration look like in a micro-frontend world? Something to definitely mull over as you think about applying this.
And as one of the sources hinted, the technology itself, especially around module federation, is still evolving. There's likely even more technical depth to explore there in the future, particularly around new challenges and solutions emerging with things like Module Federation 2.0,